This is Radio Free HPC, and I'm here with Larry Jones from Seagate. How you doing today, sir?
Absolutely fabulous.
Well, great, great. You know, we normally just do this on the phone with radio, but we got a nice camera crew here, so I thought, you know, let's find out what's going on with Seagate. So why don't we take it from there? What's new at SC15?
We're completely revamping and expanding our product line here at Supercomputing 15 here in lovely Austin, although it's a bit rainy today, but we'll overlook that. It's really a major expansion from what we have been. We've been known as a first-class luster supplier, but we're now moving much more broadly, sticking to HPC storage, but adding GPFS to our lineup and also adding a Tier 2 storage and object store for HPC storage.
Okay, and I know my friends at IBM would want me to remind everybody that GPFS is now known as IBM Spectrum Scale.
Fair enough.
Same, yes. But that sounds pretty exciting. So the expansion of your ecosystem, you know, because GPFS does a lot of things that Luster simply didn't, right?
Yeah, what we found is that there's typically sort of two different customers. In the core sort of HPC markets of research, academia, weather for instance, hardcore Luster users, they love the scalability, the cost factor is important to these folks. On the other hand, as you move into more commercial environments, think about life science here, financial services, these folks want to do things like, back up their data. So the features in Spectrum Scale, like snapshots, for instance, integration with Tivoli, the HSM integration, those are all highly valued in these other parts of the market.
Okay, well, I brought your slides up. Why don't we go through that and find out, you know, all the announcements for the week. I did? Okay. Well, give me the pitch like I was on the phone.
Fair enough. So again, it's a major update to our product line here. One thing that I failed to mention that is pretty important is we're introducing a new disk drive. Being from Seagate, it probably doesn't surprise you, but it's the first disk drive, to our knowledge, that's ever been introduced at supercomputing at all in the history. And the reason for this is this drive was designed specifically for big data requirements. And we'll go into that in a bit more detail, but that's the other announcement that's happening here. So 3 new versions of our ClusterStor product line. The L300, it's our next generation Luster platform. It's our current generation is running kind of 5 out of 6 of the systems that are running over a terabyte a second. So this takes it up the next level. Then, as I said, we added IBM Spectrum Scale to the lineup here to address those more commercial markets. So that's the ClusterStor G200. And then we have the ClusterStor A200. That's our tiered archive product. So for customers who have bought a primary storage system and then are looking to, what do I do with this big data? If I put it on tape, it's pretty much gone to cold storage for good. On the other hand, if I have an active archive, I can get it back, reprocess it, reuse it relatively quickly. So let's dive into the L300, the ClusterStor L300 product. It's a major performance upgrade for the system, so it increases the performance by somewhere between 1/3 and 1/2, depending on which disk drive complement you choose. And importantly, once you've got the performance in the system, then you need to get it out to your users. And so we've upgraded the network interface as well. The network interface moves to EDR, 100 gigabit EDR, and OmniPath. So Intel's new network interface will also be made available on the L300 in day 1. One of the other things that we're hearing very consistently across Luster, GPFS, everywhere we go is, you know, increasingly my workloads are mixed. You know, gone are the days when it was just streaming I/O. Really these days I'm looking at much more of a mixed workload. Can you help me out with that? So we're doing some things there to help the mixed workload performance on Luster.
Okay, like mixes us file sizes, like lots of small files, lots of big files.
Exactly. So typically it's been just give me a gigabyte file and I'm going to dump it off to storage. Checkpointing, for instance, is the classical use case here. But increasingly people are saying, well, there's just a wide array of file sizes and usages that I'm putting this compute system to work for, and I need my storage system to be able to keep up with that. I mentioned the new disk drive. So this is the ClusterStor HPC drive is what we're calling it. And it's the secret, or one of the secrets to handling these mixed workloads. It's a 4 terabyte drive, 4 terabyte SAS, but it's interestingly a 10K RPM drive. So typically what you find in this environment is 5200 or 7200 drives. This is a 10K drive, but at a capacity that's much larger than you've typically found 10K drives in the past, because that's what is required for HPC and other big data workloads. It's also a hybrid drive, so as you can see here with these graphs, certainly it speeds up the sequential performance by about 50%. It does roughly the same thing for random read IOPS, but the random write IOPS increased by a factor of between 3 and 4. And so that improvement is really driven by internal to the drive is a flash tier, and that flash hybrid tier allows for much better random write performance as well. So this is integral and part of both the Lustre and GPFS offering that we're bringing to market. Okay, so the small block accelerator is another feature we've added to our ClusterStor platform. So it will be available to both Lustre and GPFS. What it does is act as a filter driver as data is coming into the system. It figures out what the small data packets are and peels those off and writes those to flash. So you get the benefit of flash for those small random writes. Large sequential writes go straight through and down to disk. So it uses the media to its best advantage. Importantly, we're also moving to the next generation of networking for the Lustre system. So we moved to the next generation CPU, a Haswell class CPU. This is for our embedded storage controllers. They're embedded in each storage building block, so you don't have external servers that you have to mess around with wires and cables that are relentlessly always either wrong or failed. So it's embedded right in the storage system. And then, of course, you need to get that data back out. So there's a PCI slot that's available for either OmniPath or Mellanox EDR, and it will also support, of course, 100 gigabit Ethernet as that becomes available. So all of the networks have been upgraded from 54 right up to 100 gigabit in this generation of the product. We are also addressing a new version of our secure product for Lustre. So this is really designed for primarily the defense and intelligence agencies, and it really implements a security protocol developed by the NSA called multi-level security. So this is designed to fit into the ecosystem of MLS-enabled databases and other tools that are available in that secure part of the market. And what this does is provide the secure storage. So all data is labeled before it goes to disk. Those labels are read as they come back, and unless you have the appropriate security role, you'll not be able to get access to that data. So we introduced a new version of this on our latest hardware platform with some important software and security updates. Moving right along to Spectrum Scale, that actor also known as GPFS from our friends at IBM. It's using the same platform that we've developed for Lustre. So it has all of the goodness that has been developed over the last 5 years as we've rolled out the ClusterStor platform. But in this case, we've now added GPFS to the mix, again, as we discussed earlier, for particularly those more commercial markets where they need the broad feature set that spectrum scale provides. Again, some of the differences between what we're doing and what other folks are doing are really delivering, first and foremost, the only declustered RAID platform for spectrum scale on an x86 platform. And why you care about that is because we're delivering 8 terabyte drives now. 10 terabyte drives, trust me, are right around the corner. And it takes approximately a day and a half with traditional RAID to get that failed drive reconstructed or rebuilt. With our declustered grid RAID capability, that happens in less than 6 hours, even on a 10 terabyte drive. So that's a pretty important feature. And also, we have implemented both the flash for metadata in GPFS. And again, why you care about that is more often than not, you find in these workloads a lot of small, mixed, random I/O. And what we've done is create a pool of storage inside of GPFS that is dedicated to metadata. And so if I'm creating a file, deleting a file, or modifying it, that happens out of flash rather than having to go all the way down to disk and back. And so again, really making it easy to handle those mixed workloads so people don't have to have separate storage systems or buy the wrong storage system for their particular environment. So those are really only found in the Seagate environment. This is an example of how we're implementing that flash environment. So we have either 2 or 4 SSDs inside the storage system itself. So as the storage servers, the controllers, the NSDs write their data, metadata out, it automatically goes to the metadata pool on flash, and then the user data goes off to the spinning media. And we spoke about grid RAID, and again, what we do with grid RAID is use all of the drives in one of the drawers in the system, so all 41 drives in that drawer as a RAID pool, and that's the secret that allows us, instead of a RAID group of, say, 10 drives, we have 4 times as many drives to spread that work over, which gives us the advantage in terms of rebuilding those failed drives. And the importance there is not only to get yourself back in full protection, but also if you're writing stripes broadly over LUNs that have failed drives in them, you're typically going to run across that slow LUN, and that slow LUN is going to actually decrease the performance of the entire stripe, not just the one that happens to be in reconstruction mode. So getting back up to full coverage also gets you back up to full speed. So last but not least, the A200. So this is our Tier 2. This is the system that allows us to leverage initially the Lustre HSM system, which was brought into the Lustre ecosystem in Lustre 2.5. So Robinhood is the policy manager, the various data movers. What we've done is create a custom data mover for our A200 system, and it allows us to, under policy control, move data out to that second tier of storage. Then as the user needs access to that data, so they go and open a file which actually isn't on the primary storage system anymore, it will automatically go out, pull it from the A200, and bring it back at speeds up to 10 gigabytes a second. So if you think about tape, where you would be screaming at 1 gigabyte a second, this is much, much faster access to the system. And that's really why you would deploy a second tier, because if you don't need that performance, tape is going to be less costly for that cold storage kind of application. So for the ClusterStor A200, basically we present an alternative to customers who have large data sets for their HPC system. And we say, well, if that data that you have on that primary storage system is going to be active, you're going to need to get it back. What's the performance that you need for that data? The second side of the coin is, well, if I need to put in a second tier, it better be a whole lot cheaper than primary storage. Otherwise, why bother? I'll just expand my primary storage. Since we make primary storage, we're very good with that choice as well. But this is really designed to sit between primary storage and tape and provide both an economic and a performance benefit to the end customer. And part of how we do that is with an erasure coating, which is kind of the next generation of our grid RAID that I spoke to you about just earlier. And we're able to stripe across the entire rack of drives in the storage system. And even though we're only using 10 gigabit connections, it's all very low cost, a single controller per storage unit. Because we can use the aggregate of all of those resources to get your data back for you, we can still deliver 10 gigabytes a second or more from that storage system. And so that's really the functionality that's provided by our HSM system, being able to let the users under policy control move that data off to that second tier and then bring it back automagically when they need it simply by opening the file. So that's really the roundup. 3 new products. One is a major update of our existing Lustre product, and then adding both Spectrum Scale / GPFS, and then our A200 tiered archive.
This is exciting. I mean, it is, as you said, this is a real comprehensive soup to nuts. Everything's new this year from Seagate, sounds like.
Yeah, it's been a busy year back in the R&D area in Seagate, but we think it's going to be a good year going forward.
Well, I want to thank you, Larry, for sharing this with us, and I hope you have a great show here in Austin, Texas.
We're really looking forward to it. Austin is one of my favorite towns anyway, but then to have supercomputing in Austin, it's always a good time.
Yeah. All right. Well, that's it for the Rich Report, folks. Stay tuned for more news and information on high-performance computing.